Ladies and gentlemen, please welcome the Senior Vice President of the Engineering and Technology Group at the Aerospace Corporation and member of the AIAA SciTech Forum Executive Steering Committee, Chuck Gustafson.
Good morning, everyone, and welcome to Day 2 of the 2017 AIAA SciTech Forum. More than 3,000 of your colleagues from across the U.S. and around the world are here in Grapevine this week, and I hope you've taken the time to reconnect with old friends and colleagues, as well as meet new people and build networks that will help each of you shape the future of aerospace. Speaking of a legacy of shaping the future, how about that video we just saw on the 100 years of amazing work done by Langley Research Center? Yeah. And yesterday's 360 Forum panel of current and former Center directors was fascinating. We will really get the celebration started tonight when we toast Langley Centennial at 6:30 p.m. in the NASA booth during the opening reception in the Exposition Hall. Also, congratulations once again to the 2017 class of Associate Fellows, which were installed last evening at our annual Associate Fellows Recognition Ceremony and Dinner. It is always a wonderful event. Let's give our new Associate Fellows a round of applause to acknowledge their accomplishments. And let me take the opportunity to also thank the sponsors of the 2017 AI SciTech Forum that you see behind me. Without their generous support, we could not bring you this forum. We have 3 housekeeping items. First, whether you are here in Grapevine or watching on live stream, we are using the Conferences I/O site for speaker questions during the plenary and Forum 360 sessions. The URL is AIAA.cnf.io, and there you can submit questions and read speaker bios. More information and instructions are available in your programs. Also, keep tweeting from or about the forum and participate in our Twitter contest this week. If you use hashtag AIAA SciTech in your tweets, you could win some great prizes. Look for details in the program and the Twitter boards around the hotel. And please note that after this plenary session, we will have some reminders about the rest of the day, so please stay with us for those important announcements. So aerospace innovation constantly disrupts the status quo, whether it is a new process, a new discovery, or a new technology. In recent years, we have seen a great disruption and transformation in the execution of space exploration missions, shifting away from solely government organizations to the realm of commercial companies and public-private partnerships. These changes are primed to make today's dream of human exploration of Mars tomorrow's reality. Dava Newman, the Deputy Administrator of NASA, is here this morning to help us understand these dynamics and how they drive the innovation necessary to carry out NASA's journey to Mars. But before we hear from her, it is my pleasure to welcome to the stage Keoki Jackson, Chief Technology Officer and Vice President at Lockheed Martin Corporation, to say a few words about this morning's plenary speaker. Keoki.
Well, thank you, Chuck, and good morning. It's my pleasure to introduce this morning a truly visionary aerospace leader who I've had the pleasure now of knowing for over 27 years, since we were graduate students together in MIT's Manned Vehicle Laboratory. Now, one of her more dubious distinctions is that she chose me to be her first PhD student as a newly minted faculty member. That's a rare slip-up for which I personally am eternally grateful, so thank you, Dava. So today, of course, Dr. Dava Newman is the Deputy Administrator of the National Aeronautics and Space Administration, where she began her duties in the agency in May of 2015. Along with NASA Administrator Charles Bolden, Dr. Newman is responsible for providing overall leadership, planning, and policy direction for NASA. She performs the duties and exercises the powers delegated by the Administrator. She assists the Administrator in making final agency decisions and acts for the Administrator in his absence by performing all necessary functions to govern NASA operations. She also is responsible for articulating the agency's vision and representing NASA to the Executive Office of the President, Congress, heads of federal and other appropriate government agencies, international organizations, and external organizations and communities. Now that's a real mouthful, but the bottom line is she's responsible for the day-to-day operations of an organization with a budget over $19 billion and over 17,000 direct employees that is truly leading the world both in international cooperation and the advancement of aeronautics and space for today and for the generations to come. Now, prior to her tenure at NASA, Dr. Newman was the Apollo Program Professor of Astronautics at the Massachusetts Institute of Technology in Cambridge. Her expertise is in multidisciplinary research that encompasses aerospace biomedical engineering, including research studies carried out through spaceflight experiments, groundbreaking simulations, and mathematical modeling. Her latest research includes advanced spacesuit design, the dynamics and control of astronaut motion, mission analysis, and engineering systems design and policy analysis. Now, while at MIT, she was also the director of the Technology and Policy Program from 2003 until she moved to NASA. Now, Dr. Newman has published an aerospace engineering textbook and more than 250 papers in journals and refereed conferences. But what you may not know is that she was awarded for the best inventions of 2007 by Time magazine. She was featured on Wallace and Gromit's World of Invention. And in 1991, she set the world speed record for women's human-powered hydrofoil. So on top of that, she's a competitive skier. She's circumnavigated the globe in a sailboat. And I venture to say that she could take on anyone in this room in a game of basketball. So she truly is a Renaissance person of incredible vision, energy, and passion. Now, she once told the graduate class of MIT, "I think the intellectual horsepower of our surrounding environment calls us to action. Don't be passive, create. Create something, a club, a sports team, music, art. Let us all act, and act with compassion." But let me allow Dr. Newman to give her own call to action here. So without further ado, please welcome NASA Deputy Administrator, Dr. Dava Newman.
Thanks. You get a hug. Thank you very much. Good morning, everyone. Thank you. It's great to be here. This is a special conference, so thanks to AIAA, Kyoki, thanks for the great introduction. Without further ado, let's take a journey. I'd love to take you throughout the solar system. So at NASA, and I think for all of our research, really the enduring questions are we alone? Are there habitable planets? And is there life out there? This is an incredible, one of my favorite views from the Hubble Space Telescope, 26 years young. I heard there are 1,000 students. Are there any students in the audience? Typically don't get up at 8 o'clock. But I like to say, your entire lifetime, if you're 26 or younger, raise your hand, because your entire lifetime, thank you for raising your hands. Now, Hubble has been exploring, and my favorite story about Hubble is we looked really deep into a very dark spot in the sky. If you put up your thumb, something just as big as your thumbnail. We looked, kind of took a long exposure image, and we found 10,000 new galaxies. So, that's just how incredible all of our exploring is. And it tells us about life here on Earth. So, I think we've been to Pluto. We didn't know what Pluto looked like. I still count Pluto. I know it's a dwarf planet. You heard Kyoki say I used to play a little basketball. I was a dwarf, but so dwarf planets count in my estimation. And here's, we didn't see Pluto. Pluto, we thought, let's see if this works here. There we go. This is, if I can, sorry about that. There we go. We're zoomed in on Pluto 2 years ago. Now every day, we're analyzing the data, terabytes of data up to now, to take a look, discover, to see what the topographical features are. Could there be life? Could there be life in the universe? I'd like to give out a shout out, this is kind of my highlights reel, to our Dawn spacecraft. It is ion propulsion when we get to talk about innovation and technology. And it's gone to Ceres now, first Vesta, and now Ceres, another dwarf planet. Again, we had no idea what Ceres looked like, but guess what? Ahuna Mons, move over Mount Everest, because Ahuna Mons is 5 kilometers high and 20 kilometers wide. Again, these new bodies, always exploring, always finding out, and getting Juno, the goddess of Jupiter, now in orbit in this unbelievable hairy polar orbit, zooming around, and the data that's coming back from Juno and Jupiter is truly amazing. I like the bottom right picture. That's from our Juno CAM, our largest ever effort yet at NASA to do citizen science, to say, hey world, come on all of our missions with us. We're all explorers, and this Juno CAM is pointed at wherever people get on the website and wherever citizens want to take pictures. This is a great example. You might know OSIRIS-REx just launched this fall, so it is now on its 7-year journey, but it will be the first asteroid sample return. It's doing really well. All systems are checking out well, and it's headed to Bennu. So we have been to Mars for the last 50 years. We've been exploring. So I want to show you just kind of historically then the successes first.
Preliminary analysis of this data. Can you describe what you see on Mars?
Yes, it's there.
That's the best picture we used to have of Mars. Now we have HD images every day coming down. So really, all of our exploring is about the people. The craft and technology are great, but look at the people. Tried about every way possible to land on Mars.
Standing back for touchdown.
Led by the extraordinary men and women of NASA and our Jet Propulsion Laboratory. Right now, the wheels of curiosity have begun to blaze the trail for human footprints on Mars.
I just wanted to call and say congratulations to the entire Mars Science Laboratory team and really all of JPL. You guys should be remarkably proud.
So that's why I get to spend my days every day for the last 21 months thinking about how we can truly do the impossible and make it possible and get humanity beyond low Earth orbit, out into cislunar space, and then to Mars in the 2030s. So what an awesome job I've had. It's been an honor to serve at NASA. I do have a plan, and it's in 3 phases, as I just mentioned. The first phase, we're well into 16 years we've been living and working on International Space Station, doing great science, breakthrough science, and now testing technologies, looking at utilization. And then coming up is what we call the Proving Ground, phase 2, where we spend the entire 2020s really investing in the technologies, buying those technologies down that necessarily get us to Mars in the 2030s. So as I said, terabytes a day from Mars. We really do know a lot from the last 50 years of exploring with all of our rovers. So we do have evidence for flowing water now on Mars. It's seasonal, but very important discovery because we knew that there was ice on the polar caps, but now we're looking at this much closer to the equatorial regions. Now, you can't drink it. It's very high in acidity, high percolate, so it wouldn't be good for you yet. But again, really incredible recent discovery. And also want to show you a simulation, but the data from MAVEN has now, the first papers are published because we now understand how Mars lost its atmosphere. Mars today, of course, is left with 1% carbon dioxide atmosphere. Now, Earth and Mars, again, why study Mars and look for life? Because it tells us about life here on what I call spaceship Earth. But here you literally see the solar wind and the solar radiation ablating the atmosphere from Mars. So that ionization, that really is the ions leaving the Martian atmosphere. So again, Mars and Earth, both 4.5 billion years old, sister planets, but about 3.5 billion years ago, maybe something went terribly wrong at Mars. And so our MAVEN researchers and scientists are giving us these great insights now into the atmosphere and how Mars lost its atmosphere to where it is today. Mentioned 16 years, amazing research on space station. Highlight a little bit of that. Hopefully you were all with us with Scott Kelly's one-year mission and really gave us a chance to actually do the first serious omics research that we could do. You know that Scott has a twin brother, identical twin brother Mark, here on the ground. So for the first time, we could take their DNA. Now that data is all just coming out now because when Scott landed just last year, then we were able to do the DNA sequencing. And Kate Rubin's up on space station, she just did DNA sequencing on board. First time that DNA has ever been sequenced in microgravity, and she did over 2 billion base pairs. So a lot of great science coming out of station and telling us about how astronauts live and work. And this is 6 months. Of course, Scott's was 1 year, but of course the Mars mission, 3.5 years total, 600 days on the surface. So we still have to keep buying down those human physiology risks. It's about the technology. So I asked Scott when he was up there, what about the technology? Scott, what would you invest in? And here was his answer to me.
I think the life support systems that we need to keep us alive in space are ideal candidates for demonstrations for our future journey to Mars, as well as space suits. We need, I think, new spacesuit technology that requires less maintenance in space, and something that's going to be easier to work in on the surface under the Martian gravity.
Okay, so he might have known. I had a little bit of background in suits and technology. But the life support systems, again, we really are looking at what technologies, where do we need innovation, how do we buy down some of those risks? We go beyond. Now, we've grown our first plants and harvested vegetables, lettuce and some cabbages. It's always good when you have fresh food, especially when you're living 6 months, off the Earth. So there's Shell and Scott, and a Japanese colleague, harvesting the lettuce and having a little salad. Here's a look, just a snapshot of my favorite technologies that we're innovating in today, and kind of, again, buying down some of those risks and demonstrating new capabilities. So you see some of them listed there. I'll be able to highlight a few of them, but we really are using space station now for these technology demonstrations, like the expandable structures and habitats. What about fire? Humans and our robots working together. We just had phenomenal EVAs this week. And what you don't know, you probably saw the astronauts in EVA if you saw the coverage or NASA TV. But what you didn't know is every night the robotics are continuing doing the work. And now the crew, Peggy, will go out again on Friday and do the next round of EVAs. So the entire week, every day, every night, the robots are placing and doing work as well. So we really do have the synergy between the humans and robotics taking place for all of our operations currently. So I'd like to leave you with this image because I really like the image of International Space Station. Again, phase 1 of our journey to Mars. But I like to think about space station as the experiment itself. kind of the test bed. You can think about station as the experiment itself, phase 1 of this 3-part journey to Mars. Now, video. You can clap. That's an awesome video. So because, again, phase 2, the proving grounds, is 2018. 2018, we'll have Exploration Mission 1, and then in the 2020s, second mission with the astronauts on board. So again, it's not PowerPoint slides, it's real. Again, 1,000 companies working with us all across the US to bring heavy lift launch right here to the US. So amazing, amazing accomplishments. I just love to show that every time. And now this is an eye chart for you. It's an infographic. And when I showed you the Mars video in 50 years, I only showed you the successes. So truth in advertising. Here's humanity's missions to Mars for our rovers. And so color-coded from the Soviet Union and the US, NASA in blue. And what I like to show first is it's hard. It's really hard. First, we just tried to get there. We tried to fly by. Then we tried to put some orbiters in. Then come the landers. That's hard, as we were recently just reminded. So the point is, it really is global exploration. And NASA and the US, we're expected to lead, and we are leading. So it really is global exploration. And then now take a look at the last decade. All successes. I put those green checks. And so it really is NASA's craft going. Every mission we have, international instruments on every mission. And I give a shout out to MOM, the Indian Space Agency, right? I love that acronym, right? Our Mars Observer. The Mars Observer, that's India's first attempt and got MOM, and we helped them. We all worked together. So I like to say everyone's success is all of our success. Europeans now, new European orbiter to Mars. And that was a technology demonstrator, the lander, so that's okay, you know? I can give a award out for kind of feeling smart. We have to innovate. We have to break the barriers again. So Mars is hard. This is kind of humanity's attempt at Mars. And the next step, of course, with humans is even more audacious. All the 2020s, when we're firing up SLS and Orion capsule and learning how to live and work in deep space, buying down that technologies, in parallel, we'll still have the Mars robotic precursors. And this is a bit of a technology map here. We still have a lot to learn. Just pick a few favorites. Entry, descent, and landing, one of my favorites. You saw it in my movie, coming in hard. Well, we know how to land 1, maybe 2 metric tons on Mars. And as I said, we've tried every which way to land. 10, 20 metric tons? How do we do that? Well, we have to, you know, we don't know today. So we're working on it. Then once we get, you know, entry, descent, and landing down, what about ascent, right? It's a round trip. So we got to get up. Life support systems were previously mentioned. And really living off the land, the in situ resource utilization. We're just cranking up. So those are just a purview of, again, parallel paths, really looking at the technology. So a little bit more about NASA's innovation. How are we going to do this? How are we going to do something for humanity that admittedly is a really high bar, but it's the inspiration, it's a challenge. I grew up, of course, in the Apollo era. That's why I'm here before you today. So here's my message, is how we do it. We do it together. First, we do it globally, and we have to make NASA, and I shout out to academia and industry, the yes zone. When the folks come with crazy ideas, innovative ideas, say yes, and we need to invest in that technology. So I want to show you a framework for NASA that we've been working on and communicating, and kind of 4 elements, a framework for innovation, because at NASA, we're all innovators, but we wanted to say yes. We wanted to kind of raise people up. We wanted to celebrate our workforce, and also we wanted to be strategic in kind of where are we investing today and where are we going to invest tomorrow. So this is this kind of matrix, if you will, for innovation, and the green down the bottom, you say, again, all ideas are great ideas. Put your ideas, let's say, into this innovation portal, and what we do is continuous innovation, and that's about 80% of really what we do. It's great. You can do it with existing technology, and you can do it with existing business models. For us, organizational models, but you're just doing something better every day, kind of the mantra. So every day you're trying to improve. And then if you go over to the left, that would be disruptive innovation. You're really disrupting the business model. To the right, the darker blue, that's revolutionary innovation, kind of technology breakthroughs. Up to the top, if you want to transform both the technology and the organization at the same time, that's tough. Call that transformative. Okay, well, love to give you some examples here of what we're doing. There we go. So continuous innovation at NASA. Now, we collected some promising practices and what we're doing, and that's hundreds of examples. So I'm just going to highlight first. But again, continuously, we have all these great things that we're doing, and we wanted to share them across all of from each center, across the agency, and again, lift people up. And so first and foremost, here's digital learning networks. This is educational, great innovation, connecting, really trying to reach the thousands to the millions of kids that we can. And so from our Langley Research Center, happy 100th anniversary to Langley, too. Shout out to everyone who's here. But incredibly inspiring, and no child is too young to get connected, to inspire, to say, what's your dream, and we need you. Give that message. We also ran Mission STEM, what we call Mission STEM. That's STEM education for all. And Mission STEM was we invited and we got together at NASA headquarters, everyone that we give a grant to, all of our grantees, and said, we all need to be talking, we need to innovate, we need to be better. Now this is about raising everyone up, being inclusive, infinite diversity in infinite combinations. I learned that from the recent 50th anniversary, in case you're not a Trekkie fan. But I think Roddenberry got it right in the 60s. So again, benchmarking, where are we doing, how can we do better, and working together. That was our Mission STEM Summit. It was in August. It also was with all the science agencies, so NSF and NIH, and bringing everyone together across the government, and then with academia and having that discussion. So moving to disruptive, the disruptive innovation was mentioned actually a little bit earlier in the introduction to what we're doing. I call it the new NASA. Again, amazing partnerships, public-private investments, really very disruptive, and things are going well. I also look at our citizen science. I mentioned Juno, the mission. Again, we're saying we want the world to come explore with us. We want to open it up to everyone. Again, every boy and girl out there, all the public, so that they can explore. They can really feel like they are setting footprints on Mars or exploring Jupiter with us. Challenges, again, new kind of disruptive models, if you will, open challenges across the gamut. We have dozens of them going on, and then especially for International Space Station, really buying services now, buying services for our cargo and also for the crew under our crew cargo contracts, and really looking at partnerships innovatively, and everything's going well. And also on this slide, so shout out to Orbital and SpaceX, but I also want to make the point how great. We're working with our international colleagues. So, of course, Russia and JAXA also bringing cargo and astronauts, of course, for Russia, and JAXA cargo deliveries to space station. So we're really all in this together. Take a look at revolutionary. So just a few of my favorite examples. Of course, I am an aerospace engineer, so have to think about blended wing body aircraft, the supersonics, low boom supersonics that are coming, just incredibly transformative. This really is revolutionary technology, innovation. So the future of flight does look like this. It's coming to you very soon, we hope. And so up on top, the low boom supersonic demonstrator, again, just as fantastic. Great data's coming out. The ultra efficient aircraft in the middle with 50% fuel reduction, 50% noise reduction. I love that as a goal. Now that's innovation. It's not 1 or 2% drag reduction, no. 50% fuel reduction. I just love that as a goal coming out of aeronautics. And not to be missed, the hybrid electric. Looks small there, but I kid you not small when you get 7 electric motors on each wing for 14 wings across that span. And then James Webb, now at our Goddard Space Flight Center, is just amazing when you go and see that. Those 18 articulating, gold-plated mirrors, the control adaptive algorithms for those mirrors are just awesome. I mean, incredible, great investments here, and very innovative of what we can do. And Dr. Mather, NASA's our Nobel laureate, he tells me I can say that James Webb is going to be 100 times more powerful than Hubble. We can't even imagine what Hubble's given us. So I just can't wait for 2018 launch of James Webb and what it's really going to unreveal to us about dark matter, dark energy. That 96% of the universe that we don't know about yet. So amazing innovations. And then to transform the organization and the technology at the same time. It's hard, but that's why we do what we do. That's why we're all here. We want to do that. So again, examples of it. Again, I put space station up there for 16 years. We've been working on that. Had to give a huge shout out to exoplanets. 20 years ago, we didn't have this discipline, right? The precision with what we're measuring. Now there are, I guess, 6,000 candidate exoplanets, and 1,200 of them we've released in a catalog. So 1,200 of them are up now in a catalog. And then there's a couple dozen that are in the Goldilocks zone, right? Not too hot, not too cold. Life could be there. Just kind of the perfect recipe for life. So this is, I love these retro posters as well. 51 Peg B was the first exoplanet, again, just 20 years ago. And now, there's dozens and dozens a day. Just amazing. So I want to come back to Spaceship Earth, as I call it, after Bucky Fuller, and really all of our exploring out to find new exoplanets, but again, kind of get grounded back here on Earth. This is from our Discover mission. It's my new screensaver. You can download the app if you want to see it. That really is the far side of the moon, because Discover is at the Lagrangian point. So Earth and the sun, and then halfway in between at L1, we have this Discover mission. And so what it is really a space weather buoy. It's looking at the sun and saying, hey, Earth, 1.6 million kilometers, here's your weather, here's what's coming from the sun. So it really literally, plus it's gravity neutral, hanging out in the Lagrangian point. So I love it. Being a sailor, it's like, this is the best space weather buoy we have out there, telling us, what's coming. And then you get to see the orbit, of course, of the moon passing Earth as well. So again, just amazing. We have, for Earth Sciences, we have 20 orbiting Earth satellites today. And of course, at NASA, we design and build and fly and work with all of our sister agencies, NOAA and USGS, as they operate and take the data. And then you say, oh, there goes Space Station flying over. So really incredible investments for the world and for all of us. And then I like this image. It's artistic, but also it always reminds me to think of how frail our atmosphere is and our life support system. I'm always thinking about life support systems, but if we shrink Earth down to a basketball, make Earth my basketball, then our life support system is three human hairs thick. 3 human hairs thick is that green glow in our entire life support system. Right now, what separates us. So pretty lucky for us on Earth, it's worked out pretty well. Put this in because I had the great privilege to be cold recently, and went to Antarctica. And again, why? Because of the science, because of the breakthrough science to make sure that we're monitoring and measuring. And so we have aircraft on the top left, to your top left, that's our ice bridge mission, flying in a season in Greenland, and then going to the western Antarctica to measure the ice. The flow of the ice in the western Antarctica is more rapidly changing than we've ever seen before. So for 8 years, we've had the ice bridge missions going. Now, IceSat is a satellite, but we're waiting for IceSat-2 to be launched. So we're getting the data. We never stop taking data. So we're doing that with our ice bridge mission. Really, really amazing. Plus, on the right, that's science, that's data. But to me, just incredibly beautiful, artistic, view, for extreme places on Earth as well. So I'd like to show this graphic of a century of climate data. And you'll see from the average, which is white, blue is 1 to 2 degrees Celsius below the average, and yellow and red are 1 to 2 degrees above Celsius. That's 4 degrees Fahrenheit if you think in Fahrenheit. So audience participation time, you get to raise your hand when you're born. Make sure you guys are still with me. There's bright lights. I can't quite see your faces. Nope. All right, there's my peeps. All right, you students. So it's hot. 2015 was the hottest year ever recorded, preceded by 2014. And now our 2016 data is out, and hottest year recorded. Matter of fact, we just set records for 12 of the last 13 months, monthly hottest average temperatures as well. So I want to kind of leave you with what I think about a lot. Again, my entire career has been on STEM education, science, technology, engineering, math, but I've changed the conversation. I think it's important. I call it STEAMed now. And the reason I do that is because I need all the artists, the historians, the journalists. They're the storytellers, the visionaries. I'm talking about a journey to Mars. I'm talking about getting people there in the 2030s. Who paints those pictures? Who writes that poetry? Well, I know I need everybody. And I put a D on the end recently, and that's for the 3D maker generation, because there's a whole generation out there, and they might not see themselves as an aerospace engineer. Now, that's a shame. I wish they wanted my job as an aerospace engineer, but that's okay. If they don't see themselves, then it's all of our jobs. We have to make sure that people see themselves in our role and every role, and that we include them, and we say yes, that they're in. So I really think it is about changing the conversation, being very inclusive. Again, I know we get excellence through diversity, so it's changing the message. When I became an engineer, right, you had to be the best in calculus, physics, and math. Well, how intimidating is that? So it's, I say again, we change the conversation. That's not it. Those are tools, right? You want to explore Mars? You want to explore the moon? You want to work on James Webb Space Telescope? Those are the questions. And then if the answer is yes, guess what? Those are tools. You need to take math and your calculus and your physics, but they're just tools. So if we have that conversation to recruit the next generation, then we know we're going to lift up STEM. So I end with kind of an homage to the artist and the folks who have painted the pictures for NASA over its entire history. You can shout out, again, more audience participation if you know where this is in the world. Again, these are real satellite images. We use them for science, but I think that they're, again, just amazingly beautiful as well. This one's kind of hard. Any guesses? This one's in China. How about this one? That's Africa. A little closer to home. Anybody? That's in the US. We're the Four Corners region and desolation. Okay. This one I'm not going to tell you. Got to go south to South America. So from orbit, that is what the Nazca lines look like. Very beautiful and historic. Okay. Now fast forward. Andy Warhol helped us out, again, visioning, telling the story, exciting and inspiring about what the Apollo programs brought us. And my last image, how many people have seen Hidden Figures? Hope you saw it. Not enough. You guys have been here at the AIAA, just opened up. Please see it. It's an amazing book. Thank you to Margot Lee Shetterly for writing an awe-inspiring book, telling the story of the African-American computers. Computers are people. And telling the story from our Langley Research Center about these amazing women who did calculate, the orbits to get us into space. So an homage and a beautiful image by Annie Leibovitz here, Katherine Johnson, 98 years young and still with us. So what an incredible thing. Again, raising people up, celebrating our stories. And so thank you for your attention. And I think we get to open it up for questions.
So we have a few from the audience here. First one is, do you feel the journey to Mars will inspire the public towards science, or does the public need to be inspired towards science to gain support for the journey?
Yes, the journey to Mars, of course, inspires about science, but we need to do more. And again, how do we tell the stories? How do we make it accessible? I think how do we make our science accessible to everyone? I think everyone's an explorer at heart. I know I am. But again, how do we, I think the trick is, and how do all of us, we have our scientific data, we come to our professional conferences and share the publications and top science with one another, but how do we engage at a larger level? So it inspires me. Hopefully the science and the journey to Mars inspires everyone. And just those enduring questions. Was there past life on Mars? The evidence is mounting. The evidence is definitely mounting. What are the building blocks? What are the chemical constituents that we see? A lot of methane coming out from Mars, right? Yeah. CO2 atmosphere, the ice. So we just keep taking data, and I can't think of anything more inspiring. Yeah, so thanks for the question.
Sure. And the favorite one, how will the new administration change or affect NASA's goals, mission, and budget?
Well, that's the $1 million question, $20 million question, maybe the $20 billion question in our case. So I think we're doing great things. So we're having the conversation. The great thing about NASA is that we're hitting our milestones. I actually want to, I knew this question was coming. Could you show my next slide? I just anticipated someone might want to. Or I guess I do it.
Oh, let's see.
So it's just the point is, hope everybody jumps on our milestones website. And we put this together to say, this is what we're doing. This is what we, the US, we've already invested in. Here's the X-planes right there, right? I mentioned, if you want to click, get help from the back on this one, there's science is next. So just the next thing down, science. So we said, this is what we're doing today. We talked about, look at all those missions. All these we're doing today. They're manifest. So if we can hit the milestones, of course, NASA, we have to, be accountable working with all of you, all of our industry partners, our academic partners. This is inspirational. This is the high bar that NASA's attaining. And so here's multiple years, and we just hope we hope we get to do all of this, and we think the future looks good.
Great, thank you. So does the Mars focus mean we'll see less breadth in NASA's advanced technology research and fewer university collaborations?
I hope not. Just the opposite. So it's kind of a little bit about Mars and a little bit about investments. So I'll take it, as a two-part question. Again, so we're saying we need technology investments. We're saying this is where we are today on Space Station. Phase 2 will be in cislunar. We'll have heavy lift. But all those technology investments, I didn't mention all of them, but we know we have 85 technologies in our top technologies in the roadmaps. But today we're investing in, we need in-space propulsion. So we need the solar electric propulsion, life support systems, the HABs. So we get, radiation protection when you look for the humans. So here's all the technologies that we're investing in today. But again, so hopefully more investments in, research and technology. And then the question kind of alluded to, what about universities? Yeah. Well, I have to again go back to aeronautics. Just amazing what we're doing in aeronautics with the new unit and funding universities, and kind of that we need that low TRL. So right now, today, taking a look at how aeronautics has refocused that, looking at universities, university consortiums, And just again, I just love the way that being a former academic and returning to academia, usually I write proposals for a living. It's usually, answer the proposal. So say like aeronautics, okay, 2% drag reduction, something like that. Well, guess what? We're going to still write the proposal. But no, now we ask a totally different question. What's the best research and technology going on in the labs, in the universities out there? Okay, universities, you tell us, you tell NASA what you're doing. And so those are being selected right now. So hopefully it looks really great for universities. We're innovating, we're asking different questions, trying to listen and really try to facilitate that.
And that's an obvious source for innovation, is going to the universities, yeah.
Absolutely.
So how do we energize and educate taxpayers, particularly from the lower to middle working class, on the importance of investment in space exploration and technology, especially where the sentiment is often that there are bigger problems to solve here on Earth first?
Right. So age-old question, but first, act. I think it's incumbent upon every one of us. I know every day I am talking to someone about the great science and technology and what NASA's doing, and that's a good day. So I'm glad to do it. But really, I do think it takes activism. I think it takes every one of us. If we understand it, we are the scientists, we are the engineers. So we need to help educate everyone. And we have the best topic going. So, I'm always talking about it. I can't help myself. But we really, to me, it's education. And so it's on all of us to do what we can. We can be very powerful in terms of, again, setting, we just need to send that message. It's great because you're talking about facts, you're talking about data, you're talking about accomplishments. When I show the videos of the successful Mars missions, that's when it's about the people, all that excitement. Decades, most space experiments are decades of someone's life. So when it works, great. When it doesn't work, that's okay too. That's an incredible lesson learned because necessarily we need to take the risk. We're not doing our jobs, if we're not failing as well. So just being in the conversation with all of you and seeing how can we do this, part of educating people, that's actually part of why I call it STEAMed now as well. I want to make sure that when I'm talking, it resonates with everyone. Yeah. I need to know what someone's interested in. Whatever they're interested in, guess what? I can tie that to aeronautics or astronautics or technology or something like that.
Yeah, that's great. That's great. If funding was unlimited, could we make it to Mars in 10 years?
Funding is not unlimited, so that's a very hypothetical question.
Yes.
But can we make it to Mars in 10 years? Well, again, we're at Mars today. Yeah. We have 7 assets. NASA has 5, okay? We have 2 rovers and 3 orbiters. And as mentioned before, the Indian Space Agency, MOM, is there, and now the European ExoMars is there. So 7 assets on Mars today. Okay, but you gave me a decade, and the unlimited funding, that's just not going to happen. So we live in reality. But the plan we have, our Journey to Mars plan, in the 3 phases, is affordable and sustainable. We have to meet those milestones, but that's what we have laid out with the budgets that we have.
So as NASA pushes towards Mars, how does the ISS evolve? Does the science shift or the technology utilized there? Okay.
Yeah, absolutely. So for utilization of space station, since we've been there 16 years, just amazing. Again, people have, there might be 16-year-olds in the audience. If not, your sons and daughters, amazing. Their entire life we've had our astronauts in orbit. So we have space station through 2024. So we really are focused. Again, I think Mars is a horizon goal. What are the requirements in that? You should look at that in backdrive. So we really are saying with the technologies that we can demonstrate, that's why I say space station to me it's the experiment in itself. Buying down those technologies, what can we do? We mentioned DNA sequencing. We're doing, now we have the expandable there. And then we have to have the plan. We are really betting, NASA is betting, we're facilitating the commercial folks. We see a vision of low Earth orbit being commercially viable. That's what we're betting on. Yeah. When that happens, and in parallel, SLS and Orion, we're in cislunar space, we're investing in the technologies I mentioned before, phase 2. So the entire 2020s, we plan to be in deep space, back to the moon, and then Mars. So it's really that 3 phases and having a really clear plan for space station. Again, our commitments, the European ministerial just happened in December. And so all 5 partner nations now have committed and are on space station through 2024.
Terrific. So we don't hear much about one of the most important issues for human travel to Mars, radiation damage. What's being done to address that?
Right. So my top 3 list and radiation protection for sure is the potential showstopper. So we're doing the basic science, which is great. Again, you have to invest in look at the basic science. And since we do have 10 years or a decade, I think some really amazing things are going to come out. I'm really excited. Again, this is to me completely where science and technology is going to be completely synergistic, thinking about how do we protect humans in the future. So it's anything from innovation in terms of radiation shielding and structures. And so we look at it that way. But I think we look at it a new way as well, investigating the person and taking a look at their DNA, what's happening. And that's why we also, when we're in cislunar space, when we're on SLS, we do have to get out of low Earth orbit, and we'll be measuring and monitoring the radiation. Now, all of our missions that go to Mars today, so Mars 2020, you saw advertised, of course, we're there, we're Curiosity rover now. We have a rad experiment. That instrumentation is mapping the entire radiation environment. So we're getting data, scientific data today about the radiation environments. We're really going to study it throughout the whole 2020s, next decade. And we'll have countermeasures. We'll be able to, that's, put us to the task. But absolutely, for the astronaut, the human physiology of it, we have to think about protection. But again, we call them countermeasures to how can we counter some of these deleterious physiological effects, and radiation being one, musculoskeletal also being high. And what about human factors? We're locked up, 4 of us. That's my top list of what we have to take care of for the astronauts.
Sure. So maybe one last question. What transformative technologies do you see as potential game changers in the next 10 years? Really broad.
Really broad. So transformative technologies, again, the next 10 years, that's, you always get in trouble for trying to predict the future. But again, the ones that we're doing, technologies just for everybody. Here's my list. Again, I actually see wearable robotics. I actually see soft robotics. I see wearables. I think those are just in an exponential curve. And I think in terms of we're contributing to that. Again, just take some of my favorite technologies just almost right now, not even within the next 10 years, but what we've done on space station. A couple of my favorite examples are, handheld ultrasounds, right? Used to have to go to the hospital, huge, expensive machines. Well, we need that. We need portable things like that. So now we can take an ultrasound that's this big and get really high fidelity. Oh, what about filterization? Talked a lot about life support. We need breakthrough, transformative. If we do that, not just for space station and for our exploration of the moon and Mars, right now, today, we're starting to use those technologies. Clean water. What could be more important than clean water for the Earth? So again, looking at these technology breakthroughs, innovation, but also always kind of being very mindful of the dual use here on Earth.
Right. Well, thank you, Dr. Newman.
Yeah, just Dava, thank you. Pleasure. Thanks, everyone. Appreciate it.
Yeah, thank you very much for the really inspiring look at innovation at NASA and how that's fueling the journey to Mars and other endeavors too. So before we break here, a few more announcements. So remember that coffee is available from now until 9:30 in the exposition hall. Hope you'll take advantage of this time to visit with all of our exhibitors and to check out all of the new cutting-edge technology that will drive future development throughout our community. While you're visiting the exposition hall, don't forget to drop off your raffle ticket to enter the raffle for the video drone. The winner will be announced at noon on Thursday. We will have 2 Forum 360 programs today in Texas Ballroom C, one at 9:30, one at 2 o'clock. You can check your program to get the topics on those. And if you're looking for ways to boost your job skills or career prospects, please join us at 9:30 in the Mustang 4 room for a series of presentations on enhancing your soft skills. The workshop will cover networking skills, getting the most out of mentoring, navigating your career when the unexpected happens, and interviewing to make an impression. And at 12:30 today, we will have a recognition luncheon here in Texas Ballrooms A and B. Come and help honor your peers who have achieved distinction in the fields of aerospace sciences and information systems. If you're interested, you can purchase tickets for the luncheon at the registration desk. For young professionals, there will be a Rising Leaders in Aerospace Leadership Exchange speed mentoring event beginning at 4 p.m. in Grapevine A. If you are a young professional or graduate student Please join us for what promises to be an excellent opportunity to network and to build your leadership skills.